As with many discoveries, the word atom can be traced back to philosophical origin. The early Greek philosophers Leucippus and Democritus formed the first basic atomic theory that would later prove to be the foundation of modern understanding of the world. At this point, we will show to you a brief illustration of what is this atomic theory model with the help of my lab assistants.
Hi!
And here we have a block of clay and a piece of paper. So these two lab assistants, they are going to cut these pieces into half.
Into half again. To half. Again, half. Again. To half again. Another one. Another one. Another one. Again. Again. And again.
Okay, so upon doing this illustration, what can you observe or conclude to this experiment?
As we continue this illustration, it becomes hard for us because it becomes smaller and smaller.
In addition to what she said, this illustration will come to a point that this piece of paper will cannot be divided into halves anymore.
Now, the first people to really talk about the idea of atoms was the ancient Greek philosopher Democritus. He lived about 2,500 years ago, and Democritus, he said something like this. He said, imagine you have an object, let's say a piece of clay, and you cut that in half, and you take that half of that, and you will get the idea eventually. He said that you're going to come to something that you can't cut it in half anymore. Then he called these objects as atomos, which means uncuttable or indivisible. So this what exactly look like the atomic model of Democritus. And these atoms were actually dependent on what kind of matter an object is. For example, we have here a water atoms. Since water is smooth and flowing matter, then the face of its atoms will be just smooth as like water. And on the other side, for example, we have an iron atoms. Since iron is like spiky, metallic something, then its atoms will look just like this. And according to Democritus' atomic theory, the universe and all matter obey these following principles. First is that everything is composed of atoms, which are physically but not geometrically indivisible. Second, between atoms there lies empty space. Just for example, these are two models of atoms. And between these atoms, there lies an empty space between them. Third one is that atoms are indestructible. So these atoms are actually cannot... since Democritus' model coined the atomos, which is uncuttable or indivisible, these atoms are indestructible. Fourth one is that atoms have always been and always be in motion. Just like going back to the three states of matter, for example, in solids, the atoms are actually vibrating. In liquids, the atoms are slowly moving. And in gas particles, the atoms can move free from each other. And the fifth one, there are an infinite number of atoms and kinds of atoms, which actually differ in shape and size. And that's according to Democritus' atomic theory. Just for example, one type of atom is like this, and another one can look like this, and another one can look like this. With Democritus, after 2,000 years, here comes John Dalton carrying his billiard ball model. They didn't really have a big difference. The only thing was Democritus' theory was philosophy, and John was science as we understand it today. And John Dalton had a little improvement with Democritus as he coined compounds which bonding atoms forming a compound. For example, we have here one atom of oxygen and two atoms of hydrogen forming the water molecule. After this model was the onset of more different and improved atomic theory models as we understood it today. Here, with J.J. Thomson, which has the plum pudding model, and Ernest Rutherford with the Rutherford's atomic model, Niels Bohr with his Bohr's atomic model, and the electron cloud model by Erwin Schrödinger. So with these improvements in atomic theory and with atoms, say that we are actually understanding what we are, where we came from, and what made us it is as today. So with these different atomic theory models focusing on Democritus, let's say thank you to Democritus in giving us the idea of this atom, what we have understood today and what we are studying for the betterment of all and for the name of science.